Good morning. I am Tamilmani. I'm working as an engineering manager in Microsoft, and I work in the AKS networking team. And this is Shreya, my colleague, and I will let her to introduce herself.
Hi everyone, my name is Shreya and I'm a software engineer. I work mainly on Cilium Scale at Microsoft.
So yeah, let's go through this. So in this session, we are going to talk about CiliumEndpointSlice and what are the benefits and how to enable CiliumEndpointSlice in the existing clusters. So the agenda for today's meeting is we'll first start with the basics, what Cilium endpoint is, what Cilium identity is, and then we talk about the existing limitations, like what is the scale issue with the existing Cilium endpoints, and how Cilium endpoints going to help us in solving the problem, and what is the safest and best way to migrate from Cilium endpoints to CiliumEndpointSlice. And also we will cover like what are the improvements we are bringing in on top of the existing CiliumEndpointSlice. So we'll start with like how the networking is set up in Cilium, right? So Cilium runs on all the nodes, and it is responsible for setting up networking for pods through eBPF programs. It sets up the pod networking service routing. So that facilitates pods across the clusters to communicate with each other. So it provides a connectivity. So in addition, it also programs network policy for pods. So what is network policy? So usually in Kubernetes, network policy is enforced through labels, pod labels. So here in this case, you can say like the server pod can talk only to the client pod, and client pod can talk only to the server pod. So the rest of the communication from server pods and client pods to other pods should be blocked. So it is, if you see here, it's implemented through labels saying like allow for server pod saying allow app only client. For client pod saying like allow traffic only from the pod which has app equal to server. Okay, sorry. So Cilium does this through eBPF programs, implements this network policy through eBPF programs. So let's see how it does that. So Cilium identity is one of the core piece of the Cilium. Sorry. Yeah, Cilium identity is the core entity of the Cilium. So Cilium identity is generated based on the unique set of labels. So Cilium identity will have an unique unassigned 16-bit numerical identity assigned, and this will be unique across all set of labels that Cilium generates. And why we need Cilium identity? Because Cilium enforces network policy based on the Cilium identity and not based on the ephemeral pod IPs. So consider a scenario when pod scales up and scales down, the IPs will change, but the identity would not change. And Cilium enforces policy based on the identity, and it is more secure than doing the policy based on the pod IPs. So Cilium endpoint is another critical piece in the Cilium world. So it is created for every pod. Every pod will have a equivalent Cilium endpoint. And this Cilium endpoint includes information about what is the IP of the pod and what is the identity assigned to the pod. If you look at here, the identity is assigned, the security identity is assigned as 33001. And if you look at the IP of the pod, it's assigned as addressing. Addressing refers to the IP of the pod. So though Cilium enforces network policy based on the identity, it needs to know which pod IP refers to which identity. It needs to know the mapping of IP to identity, and Cilium constructs this IP cache. We call it as IP cache, constructs this IP cache based on this metadata. So it reads the Cilium endpoint information, and then it constructs the IP cache, and then have the mapping of what IP belongs to what identity. That's how it enforces the network policy as well. So let's now look at how this endpoint, Cilium endpoint and identity is getting created in the Cilium world. So Cilium agent is running as a daemon set. You can see it's running on all nodes. So it watches on local pods. So whenever a new pod gets created, you would see like a Cilium endpoint will be created for that pod. And if it is the first pod from the deployment, Cilium identity will also get created along with it. So now the Cilium will create an endpoint and then publish to the API server. So now how it gets the mapping of all IP2 identities. So it watches on Cilium endpoints. So each Cilium agent running on each node watches on all other Cilium endpoints created by all other Cilium agents. So this will eventually cause pressure on API server if your scale is very high. So let's see like how much scale it creates for a scale of 5K nodes with 200K pods, right? So create a 1 billion CEP watches. So because if you consider a scale of 5K nodes, each node now needs to watch for 200K Cilium endpoints. So in the scale of 5K, so in case of a number of watches that API server should handle, it should be 5K into 200K, which will be 1 billion CEP watches. So The right side image is generated by ChatGPT. I just gave the context, it generates the image for me. So it also, in these watches eventually bring down the API server performance. We have seen under our testing the increased request response latency, CPU memory usage of API server like spiking well, and even in some cases it went out of memory. So how to reduce this load on the API server, right? So how do we reduce this load? How do we reduce these watches and everything, right? So how then we can scale better. So that's when CiliumEndpointSlice comes and saves us. And Shreya is going to cover about how CiliumEndpointSlice works and what are the best migration practices for existing clusters to migrate to CiliumEndpointSlice. Thank you.
All right. So I wanted to start out by calling out the CFP for CES. Fun fact, this CFP came out before I even graduated. So kudos to the folks at Google and Isovalent who actually worked on the core implementation of this feature. I want to get into first how this feature works. So we start with the base concept where we have Cilium endpoints. Now Cilium endpoints map one-to-one with pods, and they're a slimmer representation of a pod in that they have less fields than a pod, but they still have more fields than we might need in Cilium. And so when we create a core Cilium endpoint, we strip out some of those inessential fields. The one I really want to call out is that Cilium endpoints actually store security labels, and we strip those out. You can imagine in a worst-case scenario, you have a pod which would have tens or hundreds of labels, and those are all going to be stored in the Cilium endpoint. But we don't necessarily need those. What the Cilium agent needs in order to enforce network policies is the identity number itself. And so the core Cilium endpoint only stores that. It also strips out a few other fields, so we have a slimmer representation. Now we take this representation and batch it into a Cilium endpoint slice. So there is a controllable field in the CES controller where we can say, hey, this is how many core Cilium endpoints we want to batch as a maximum in each Cilium endpoint slice. And we're going to batch based on that. So by default, we batch up to 100 core Cilium endpoints into a single Cilium endpoint slice. Cilium endpoint slices are internally batched by namespace. So in each namespace, we create different Cilium endpoint slices, which contain only the core CEP representations for pods in that namespace. And we're going to batch them into the Cilium endpoint slice that has the most available slots in order to minimize the number of updates made. I'm going to get back to that in a second. So I'm going back into how the mechanics of our cluster are going to change. So we originally had the Cilium agent watching local pods. So pods on the same node as that agent are being watched. Then the Cilium agent goes back and creates Cilium endpoints to represent that. Now we introduce a new controller, the CES controller, into the Cilium operator. So the Cilium operator watches Cilium endpoints that have been created by the agent. And now it's going to create Cilium endpoint slices. So it watches Cilium endpoints. It says, hey, what is the biggest Cilium endpoint slice I have with available slots, and batches the core Cilium endpoints into that slice. And it maintains a local cache of goal state mappings in the CES controller. Now, it also runs a reconciler, and this reconciler maps the goal state mapping at the local CES cache to the API server so that the entire cluster can be aware of how the CES representation of the cluster is. So yeah, we have the CES controller watching CEPs, and at the Cilium agent, instead of watching CEPs, we now watch CES. So we're no longer watching an object that is one-to-one mapped with pods, but one that is actually in the default scenario, you're going to have the number of pods divided by 100 CES for your cluster. So in a huge cluster, let's say we're getting up to 10K, 15K nodes, now you no longer have to watch on this object per pod. We're watching an object that consists of smaller representations, so we've slimmed down the amount of information that needs to be written to or from the API server or etcd. We've slimmed that down. We batch the updates, so if I'm going to talk about the best case scenario because I like CES. So in the best case scenario, you have, say, 100 pods in the same deployment, so same namespace, same labels. These are all going into the same CES. Instead of getting 100 updates for each create or a label change on those pods, we're going to get a single update at the API server and a single watch back to the Cilium agents. And remember, the Cilium agents are a daemon set, so you have one running on each pod. So this watch benefit is really impactful on the cluster. So at AKS, when we decided to deploy this into production, we did see a significant improvement. So I'm calling out results with a limited API server SKU where we struggled with CEPs. Once we introduced CES, we saw a 3 times improvement in node scale. We also saw much improved faster API responsiveness. So when I refer to API responsiveness, what I'm referring to is the latency at which the API server is responding to requests made to it. And so when we aggregate those responses, we saw 50% improvement. We also saw 60% faster pod startup latencies. So I want to say that this is mainly because we were doing this testing with a small API server SKU. And with this limited SKU, our control plane gets severely overloaded with Cilium endpoints. And so once the control plane is freed up, we are able to get through the processes at the API server much more quickly. OK. And just for fun, because everybody loves numbers, I'm going to point out a few more results from our scale testing. So these are scale tests that I ran recently, so with a more updated version of Kubernetes. These were run with a 1,000-node cluster. I created and delete 100 pods per node, and this is all using the upstream Kubernetes CL2 configuration. So we create 100 pods per node. I scattered these pods amongst 100 namespaces, and I varied the deployment sizes, so I had big, medium, and small deployments. And each deployment had a service associated with it. So big deployments had, I think, 250 replicas, medium with 100 replicas, and small with 10 replicas. And then I also, for the fun of it, dispatched network policies. And these network policies target about 500 pods in every namespace, which if I'm remembering correctly, is about half the pods in the namespace. OK. So before you consider dispatching CES into your production clusters, I would definitely ask, hey, what's the possible downside of this? And so the possible downside that might come to your head is, hey, we are batching updates, but these updates now are being made at the CES controller in the operator, and then they need to be reconciled at the API server. So what is the latency impact of that? So that's what we took a look at too. Hey, is this trade-off going to be worth it for us? So at very high throughput, we see, so this turn testing has been done with a throughput of 100 pods per second. At this throughput, what was the endpoint propagation delay? So one metric we had was the CES queuing delay. So the CES queuing delay is, hey, how long are these updates staying in the queue at the operator before they're reconciled at the API server? And in our churn testing with the highest possible churn, this was less than a second throughout the test. It does hit the maximum of 1 second. And similar for endpoint propagation delay, so how long does it take between us seeing a new endpoint and reconciling that with the API server? Also about 1 second throughout the test. And so it can come to you. You can say, hey, these updates could be delayed by about a second in the worst case churn scenario, but your API server is not going to be overloaded, and your control plane is not going to be overloaded. So is it worth it? I think so in most cases, but obviously it's up to you. OK, a few more metrics. These are kind of things that you might expect to see. But what is the number of lists per second for CEPs at the API server? So you do see that these drop significantly from the hundreds to almost less than 1 per second. Pretty expected, because no longer the Cilium agent daemon set is watching the Cilium endpoints. It's just the operator issuing these commands. It's going to be a similar thing for the watches, which are also dropping. Similarly, for the Cilium endpoint list latency, so now we have the control plane much less overloaded. Our latencies are going down simply because there are much fewer requests being made. The API server is able to handle these requests more efficiently, more quickly. Okay. So now let's say I've been a very convincing speaker, and I've convinced you all to enable CES on your clusters. How exactly are you guys going to do that? So for migrating to CiliumEndpointSlice, the steps you'd follow are this. In order to avoid any network connectivity disruptions, the first step that you want to take is to roll over your operator and enable CiliumEndpointSlice on your operator so that the operator is creating CES. And then we would enable it in the agent so that the agent stops watching CEPs and is watching CES. You wouldn't want it to do it the other way, because if you have the agent stop watching CEPs, it might not get the latest changes on the data plane. You could have a network connectivity disruption. All right. Another key thing to remember is that we want to kind of wait for all of the Cilium endpoint slices to be made before we roll over the agent in order to minimize any endpoint propagation delay. How can we track that? Well, there is a metric for it, of course. You could look at the API server storage objects and see, hey, have the number of CES balanced out. You can also kind of approximate it if you use the Go QPS at the operator. What are some other metrics you might be interested in? Well, the CES queuing delay, so how long are your updates being delayed, is something you might want to monitor on a cluster with CES enabled. You might also want to look at the service implementation delay and the policy implementation delay to see what's going on at your data plane. So delays here are important because they're going to tell you, hey, this is how long it's taking for changes to be propagated. And if your delays are getting too high on your cluster, you might want to look into tuning your configurations. So I want to switch tracks here into how exactly you can tune CES to optimize it for your cluster and for your scenario. So one configuration that you might look at is the dynamic rate limiting that we have in the CES operator. So for dynamic rate limiting, you are able to set the rate limit at which you can set the QPS for propagating CES updates. And you can set this actually by cluster size. So if you have different cluster sizes available, you might have a smaller cluster where a lower QPS works. You might have bigger clusters where you need a bigger QPS, but also limited enough to not overload your control plane. And so you can find a balance of that. Another configuration that is available is slice sizes. So I mentioned before that the default number of core Cilium endpoints batched into a slice is 100. If you have smaller slice sizes, that might help reduce your propagation delays. And if you have bigger slice sizes, that's going to help you fit more updates into a single CES update. And so that might help if you have a really overloaded control plane. So again, these are things you can fiddle with a bit in your testing in order to tune it for your scenarios. And then the final configuration we have is for our priority namespaces. So let's say you have a namespace which you want to guarantee gets updates to the API server before other namespaces, then you can annotate that namespace to give it the priority, and the CES controller is guaranteed to process those updates from those CES before other updates. Okay, so I want to segue a little bit here into what's next for operator-driven scale and security. So the first thing I want to call out is this CFP, which is actually fully implemented in upstream now, and it comes from Google. There is another possible scale issue, which could come up in terms of identities, wherein it is possible in a worst-case scenario that the Cilium agents are all creating identities for the same set of labels at the same time. So this CFP implements a change to move identity management to the operator, thereby basically eliminating this identity problem and improving security posture. I also want to call out one more change, which is currently being upstreamed, actually by us. So if you were paying attention through this presentation, you might notice that there's a little bit of duplication of data in your cluster. So you have CEPs and you have CES, which contain a lot of the same data, but we still have CEPs in our cluster. So what we're currently working on is removing CEPs from our cluster and seeing if we can improve control plane performance by completely eliminating the CID, which is one-to-one mapped with pods, and boosting how CES performs. So, yeah, that would be it from us. But we're happy to take questions. It's a part of Cilium open source.
Can you repeat the question?
Yes, the question was, is this part of core Cilium? And it is available in open source. CiliumEndpointSlice, I believe, is available from 1.17.
It was available from older versions, but it becomes stable from 1.17.
Yeah.
Say we try this. Sorry, can you kind of decided that it doesn't meet our business needs? How hard is it to actually offload? How hard is it to actually get off of CES after we tried it? Like, let's
So
say
you want to
we
roll
did-
back
yeah,
from
roll
CES?
back, yeah.
So to roll back from CES, basically the reverse procedure. You want to roll back the Cilium agent so that it starts watching CEPs instead of CES. And then you roll back the operator because we no longer need to create CES.
Is that still the case if you're on your roadmap? You say you're going to get rid of CEPs, right?
Yeah. Same thing. Like if you wanted to move from CEP to CES, you would do the same thing. Like first to make sure operator creates identities.
Mhm.
So operator creates endpoints, and then you disable the Cilium endpoints from Cilium agent.
Got it. Okay.
Are there any more questions?
Probably talk loud enough, but I got you. Is there any downtime with that when you switch over to CEP or CES? When you switch to the endpoint slices, is there downtime?
There's no downtime. It's like just as we roll over the operator first, so it creates the CES while the agent is still watching CEPs, so there wouldn't be a connectivity disruption. And then we switch over you roll over the agent, and so there's going to be a rolling update, so it's still going to be processing those updates.
So for the slice size, chosen red slice size, you said default is 100.
Yes.
Suppose I have a cluster with the deployment maximum has 30 replicas. Should I choose 30 instead of 100?
I think it depends because so it's like if you have only 30 pods on your cluster, so maybe
No, that's just a maximum replicas for one deployment.
right, but you might have multiple deployments in a
we have
namespace.
multiples. Yes.
Yeah, so if you have multiple deployments in a namespace, it might make sense to have batch your updates into a bigger batch. That might provide some benefits depending on how many pods you have. But I also think there's a scenario where you could more efficiently propagate updates if you know, hey, all of my deployments are only going to be 30 replicas. There is a counterpoint there is that although these updates are batched first come, first serve, let's say you create 2 deployments at the same time, then your pods are going to be scattered into different slices if they only have a maximum slice of 30. So that might be a downside in that your updates are anyways going to touch multiple slices, so you might not see the benefit of having only 30 as your maximum slice size.
Okay. Another question is, you said the migration and the rollback procedure, but we are doing the chart installation, right? Upgrade. So it's not just parameter change.
Yes.
But do we need to do the 2-step first?
Two-step for the safer rollout. You will first change the operator to enable CES so that it watches on Cilium EndpointSlice and disable the agent side endpoints creation later, the second step.
We cannot do one at
Yeah, in one, there will be a possibility of disruption. Without disruption, its safest way to do it is a 2-step rollout.
Okay.